So good morning everyone. I am PrajnaParmita. I am an assistant professor from Civil Engineering Department in Assam Engineering College. So I have recently joined Assam Engineering College. Earlier I was an assistant engineer in Water Resource Department of Government of Assam. I have done my degrees, my specialization in water resources engineering and management. So it's like I do not have huge knowledge or like huge knowledge in floodplain zoning in Assam or the flood problems, but throughout my like study or throughout the years in the water resource department, I have gone through some of the projects. I was associated with various projects related to the modeling part of the flood mapping. So from that I have gathered some knowledge and I want to share that experience with you. So I want this session to be like interactive one because maybe you have more experience than me. So if there is any question or you want to share something, you can share with me. It should be like a both way session. It should not be the thing I know I will try to deliver, and at the same time I want from you also, so that it becomes an interactive session. Okay. So the floodplain zoning. So we all know Assam is one of a state in the world which the flood happens in every year. So it's not something which is like a rare disaster in case of Assam, but it's like we experience flood in every year. So the main thing is that earlier what we were focusing on that we have to reduce the amount of flood, we have to reduce the magnitude of flood. So now the perspective is how we can live with the flood safely. So the scenario has changed from reducing the magnitude of flood to living safely with the flood. So I think many of us has experienced flood personally. So if we want to know what is flood, as per WHO, flood is defined as the most frequent type of natural disaster, and it occurs when an overflow of water submerges land that is usually dry. Floods are often caused by heavy rainfall, rapid snowmelt, or the storm surge from a tropical cyclone or tsunami in coastal areas. So if we want to divide flood in categories, so in broad categories, how we can divide? We can divide it in fluvial floods or the river floods, or the pluvial floods, which is also called the surface water flood or the flash floods, and the coastal flood or the storm surge. So what is fluvial flood or river flood? Fluvial flood or the river flood, it occurs when the water level of the water body, it overflows and then it inundates the neighboring area. Okay. So the flood we experience in Assam, which overflows the Brahmaputra and Barak and its tributaries, it is kind of fluvial flood. Okay. And in case of pluvial flood, what occurs? It occurs due to extreme rainfall that creates flooding. It is independent of overflowing the water body, such as the urban floods or the flood that happens in Guwahati every monsoon. So that is pluvial flood. It happens due to extreme rainfall events. So in case of Assam, we have two types of floods which we need to consider. One is the fluvial one, and the second one is the pluvial one. The third type of flood is the coastal flood, which happens due to surge in the sea water, or it happens in the coast of the sea water. So it is typically caused by intense windstorm coinciding with high tide or by the tsunamis. So in context of Assam, we have to model fluvial flood and the pluvial flood, though coastal flood is not as such important in relation to Assam, but it is also if we consider the national wide scenario, then coastal flood also we have to account for. But the thing is that when we model flooding, so the approach for modeling for fluvial flood, pluvial and coastal flood, all these are different. So we have to know what type of flood it is, and then accordingly we have to start our modeling. So the flood problem in Assam, it's not new. We all know the flood problems in Assam. Every year the during monsoon we have flood. So the main one of the major problem of Assam flood is that the rivers in Assam, they carries a huge amount of sediment load, and after the flood water recedes, what happens that it started eroding the banks. Okay, and when the flood, you see, flood is a natural phenomena. So when it becomes a problem when it interacts with the human settlement, human construction. Okay, and in case of Assam, what happens, a huge amount of population, they live in the flood plains. Okay, and we all know that we have two major rivers in Assam. One is Brahmaputra and the other one is Barak, and they all have tributaries. So these tributaries and the two rivers, they form a large network of rivers in Assam. Okay, so if we see the river system of Assam also, suppose you can see the, two rivers in Assam. One is the Buriding river, it's a tributary of Brahmaputra, and Beki also, it's a tributary. So Buriding is a south bank tributary and Beki is a north bank tributary. So if you see from the pictures, it is clear that both the rivers, tributaries, they have different characteristics. So we can see in case of Buriding river, in what is this? From this figure, we can say that they are meandering in nature. Okay, and what is Beki? The Beki is a kind of north bank tributary. So how it's what is its nature? Its nature is braided. Okay. So if we compare the characteristics of north bank tributaries and the south bank tributaries, what we see, the north bank tributaries, they have very steep slopes and they are shallow braided channel for a considerable distance from the foothills, and in some cases right up to the outfall. Okay, they carry heavy silt amount and they have generally fleshy flood. You can see other also, like the Jiadhal also, it's a north bank tributary. There also, if you can see, the flood nature is flashy and they are braided channels. Okay, the south bank tributaries, whether if we see the Kopili river also and the Buriding river also, they are meandering channels and they carry comparatively low silt charges. So while designing the two types of rivers in Assam, like the north bank tributaries and the south bank tributaries, again we have to like study the river characteristics first and then start the modeling. Okay, so I think you all have gone through the definitions of this floodplain, zoning and flood zone, but it's a quick revision. So what is floodplain? Floodplain, it is the low-lying area near the river which are prone to inundation. And what is floodplain zoning? We regulate the human activities. If we regulate the human activities in the floodplains, then it is floodplain zoning. Okay. And what is zone? It is the area requires to carry flood water of a prescribed probability. Suppose I have a 25-year return period flood, and what we do, we have run the model for 25-year return period flood. So however, which amount, whatever the extent of that 25-year return period flood or that 50-year return period flood, that we call as the flood zone for that particular return period flood. Okay. And the flood zoning authority, so they may be some state government or central government authority or government authorized body, those who can enforce the zoning act, the restrictions of regulation of the LULC, land use land cover pattern in the floodplain. So you can see floodplain zoning is the land use planning strategy that designates special areas along rivers and water bodies for various uses based on their susceptibility of flooding. So the main aim of the floodplain zoning is to regulate the development in these areas to minimize the potential damage and risk associated with flood. So what floodplain zoning is, it is a non-structural flood management. See, earlier I have told you that the earlier the concept was how to reduce flood. Now the concept is how to live with flood safely. So floodplain zoning is a measure so that we can live with flood safely in the floodplains. Okay. So in case of floodplain zoning, what we do, we regulate the land use pattern in the flood prone areas and we reduces the flood damage, not the flood. Remember, with floodplain zoning, we try to reduce the flood damages, but we do not want to reduce the amount of flood. Okay. So there are three, we may divide the whole area of the floodplain into three zones: high risk zone, moderate and low risk zone. So in the high risk zone, what we do, it is generally the areas which are near to the river, okay, which experiences flood like annually or 1 in 5 years. So it regularly experiences flood. So we generally do not consider the important buildings or any important construction or residential buildings, etc. in the high risk zone. What we do, we may construct some parks, open spaces, etc. in the high risk zone. Then in the moderate risk zone, what we can do, it is slightly farther from the flood water from the river. So we may have some of the residential building or commercial building, but what we have to do, we have to tell them that suppose we are constructing a building, or suppose we are constructing some construction. So the height of the building or the foundation level, the plinth level, we have to construct it from above that flood level so that we can have minimum damage. Okay. And the low risk zone, which is far away from the river, so it experiences rarely floods, and here we can have residential building, important commercial, important structures, etc. in the low risk zone. So for the flood risk assessment, it is the foundation for the effective zoning. So if we say the robust flood risk assessment is the cornerstone of any successful floodplain zoning framework. By thoroughly analyzing the watershed, mapping flood prone areas and evaluating community vulnerabilities, planners can take informed decisions to protect lives, property and the environment. So you see, there are three main stages associated. One is analyzing the watershed. How we will analyze the watershed? We have to study the watershed. We have to study the elevation pattern of the watershed, which area of the watershed is in the low-lying portion where it has high ground, etc. And then the rainfall runoff pattern of that watershed. So we have to analyze the watershed first. So there are various hydrological tools. Also there are various hydrodynamic tools which I think you have gone through. We have heard about HECRAS, then MIC. There are other softwares like 2Flow, Delft 3D. So we can have various softwares for analyzing the watersheds, and also we can use GIS, then mapping the flood prone areas. So inundation map also we can, when we simulate the model, we can have the inundation maps, and by importing it in the GIS platform, we can like properly deliver the flood inundation maps. Okay. So after that we have to study the vulnerabilities. So when we overlay all these three layers, overlay all these layers, then we will get the hazard map. Okay. So you know flood risk concept, the risk is combination of hazard, exposure and vulnerability. So we have suppose a flood, there is a flood and the flood depth is very low, but it may have a high, more hazardous, because it only doesn't depend on the depth of the flood, it also depends on the exposure. If the flood is happening in an area where that is densely populated, there are lots of important structures, then what will happen? It will cause more damage. So it is more hazardous flood. Okay. So flood hazard doesn't mean only the depth or the velocity. We have to account for the exposure also. Okay. So there are some of the countries which already have established flood zone or flood hazard mapping. Suppose we go to the North America, for the United States, Canada, Mexico, they have already hazard maps for their country. For Europe also, they have for the whole Europe they have model. Then for different countries they have model. For Netherlands also they have model. Then in case of Asia, in case of India, we have hazard maps from CWC, NDMA, NRSC flood inundation maps or hazard maps, etc. Then globally also there are models, global flood risk database, then one is GLOFAS satellite based flood inundation mapping also there. So all these, there are lots of models for flood hazard maps, but the difference is in case of United States, but in case of United States or in case of Europe, they are already established. They have enforced the laws that these are the high risk zone, these are the low risk zones. So they have regulated the human activities in those areas. And but in case of Asia, what happens? There are lots of models which may be project based, or but we do not have like a proper which is enforced model in case of India. So floodplain zoning is not properly enforced in case of India. But another thing is that for India or for these global models, what they have done, they have used the satellite images. They compare the various flood events already happened, the historical flood events they compared. But and by comparing those flood events, they have given us the inundation map. But in case of United States, but they have also used hackers for their modeling, and they give the inundation depth, and they have incorporated that hydrodynamic modeling also in floodplain zoning. In Europe also, in UK and Netherlands also, I think they have used mic or two flow. They have developed flood zone mapping using the hydrodynamic incorporating in hydrodynamic modeling also. So we all have heard one concept, room for the river. For the Netherlands, they have adopted, I think maybe you have heard the concept room for the river. So for the room for the river, what does they do? They allow the water to flow freely. Okay. So in case of Assam, if we see what we do, we construct embankments in case of along the bank, along the river. Okay, in the bank. So what we do, we restrict the flood waves, and when there is monsoon, in some places it breaches and causes flood. Okay, but in case of room for the river in Netherlands, what they do, they have lowered the height of the dikes. Okay, they allow water to flow freely. Okay, and and then they divide the zones into divide the floodplains into different zones and regulated the activities there. So in the floodway, they do not allow any major constructions. Okay, so this room for the river is also an example for how we can change the land use land cover pattern by living safely with the floods and with the so room for the river. I think you can go through this Netherlands room for the river concept. Okay.
The CWC has adopted right of way instead of
room for the river.
In the last lectures, they have said that because of economy, we can't adopt room for river.
Room for river.
India. So they adopted this right of way.
Right of way. So in case of Assam also, SDEMA, they publish flood hazard map every year. So recently when Amit Shah ji visited, so he also inaugurated the flood hazard report. I think we have got from the news. So what are the basic data which we need for running a hydrodynamic modeling? So first one is the digital elevation model. We all know digital elevation model. So map, these we have to use for defining the geometry of the river, defining the geometry of the floodplain. Okay. Then land use land cover map. So it also helps in defining the Manning sand value, the roughness value there. So land use land cover map. Then rainfall and discharge data, which we use at boundary condition for rainfall and discharge data, and satellite images for flood extent. We can use that when like for validation purpose also we can use the satellite images for flood extent. Okay. So In Hecker's flood inundation modeling, what we do, we have the river geometry, we have the flow data. River geometry means also the floodplain geometry. It may be in form of cross sections, it may be in form of the digital elevation map. So we can use both to define the river geometry. Then we have the flow data, water level or discharge time series, and then what we get the flood depth, we get the velocity, and we get the flood inundation output. Okay, extent we get as output. So this depth, velocity or the extent we can then import in the GIS platform. Then if we overlay it with the exposure matrix, and if we define the hazard matrix, then if we overlay this in GIS platform, what we will get the flood hazard map. So I have developed actually a model in HECRAS, which later on I will show. So one way is to develop the model, develop the hazard map by incorporating the hydrodynamic modeling. Hydrodynamic modeling, or in some cases we can use the hydrologic modeling also. So other way is the GEE. GEE is the Google Earth Engine. So how we can use that? What is GEE? So GEE is basically a cloud based. It's cloud based, and it is free. It is free to all, and we can have lots of amount of satellite images through GEE. Okay. So the basic advantage for using GEE in case of Assam is that we do not have we do not have data like a continuous data series. We do not have. Suppose if we want to model different rivers of Assam, the first problem we will face is that we do not have proper discharge data, or we do not have proper silt data. We do not have proper, we have the water level data, I think, but we do not have proper discharge data. So in that case, what we can use, we can have the Google Earth Engine, where we will have access to lots of satellite images, and then we can prepare the flood hazard mapping. Okay. So why GEE? That I have said that GEE is why GEE? GEE is cloud based. Okay, it is free for all, like we all can access. And the main thing is that as it is cloud based, we do not need a higher specification computer of our own. Like we can run it on the cloud, and then we can process that the data and prepare the map on it's on the cloud. So like for HECRAS and if we want to run MIC or any other hydrodynamic modeling or hydrological modeling, what we have to have a higher specification laptop or desktop, or what we call workstation, like because otherwise what will happen, the computational time that gets increased. Okay, so we use GEE in some cases. So I have prepared. It's a very raw, like it's a very raw this one. Like I haven't validated whether it is correct or not. I have just run a code in GEE to prepare the flood inundation map for the Morigao district, flood hazard map for Morigao district. So what data I used? I used global surface water data, okay, the SRTM DM and Landsat 8 images. So what is the using the global surface water data, I have given a threshold value. So with the threshold value, what I have given, I have separated the permanent water from the flood water. Okay, and then I have calculated the distance from the water, a place for a particular place. What is its distance from a river, from a permanent water body? I have calculated. Then using the SRTM DM. Using the SRTM DM, I have developed one topographic position index, which will basically say which ground is in a elevated portion, which is in a low lying area. Okay. Then using Landsat images, the NDVI and the NDWI index, vegetation index and the wetness index I have calculated. So it is like if more wet, then it is more flood prone. Okay. So then a hazard score is given. It's a matrix basically. So when we overlay that, then the flood hazard map came out, divided the categories into very low, low, moderate, high and very high. So this is one of the flood hazard map developed in Google Earth Engine. Then in another what I have done, this is also a hazard map developed in GWE, so Google Earth Engine. So what is the difference is that here I have used the Sentinel-1 SAR data grid, and these are sorry. So what is the basic difference between these two? The basic difference is that in the first one, it's a predictive map. Like I have given the code like for a particular flood, this much area will get inundated. It's predictive, it's probabilistic. It's not happened. But here what is that in the code, they have like for the past satellite images, see in the flow chart given, I have used satellite images from 2016 to 2023, and the wet season and dry season images I have compared. Okay, so this map, it shows us the pixel which have already experienced flood. Okay, the earlier map, it was like okay, this area have a probability of flood, but this is they have already experienced the flood. Okay. So that the key differences between the maps prepared using HACRAS and GWE is that, so we have seen that we can incorporate hydrodynamic modeling also during in hazard mapping, and we can also prepare using only Google Earth Engine. So what is the main difference, key differences? So first one is what it represents. So HACRAS, it is a physically based model, so it incorporates the behavior of the river and the floodplain. Whereas in case of GWE, it is a remote sensing based. So it is a flood occurrence susceptibility map. It is derived from the satellite data. Okay, how it is prepared? HACRAS, it uses the river geometry as well as the floodplain geometry, but in case of GWE, we use only the satellite images that detects the inundated pixels during the flood events. Okay, and also the nature of the map, in case of HACRAS, it is predictive, event based. Suppose we know for if we run the map for 25 years return period flood, then we know for that particular flood how much water will go, what is the extent of flood. So what is the depth of flood? But in case of GWE, it is observational, it is historical, probabilistic, and it is frequency based. So in short, we can say that HACRAS explains the physics of flooding, but GWE shows the footprint of flooding from the space. Okay, so if we prepare the map incorporating HACRAS and GWE, what will be there? If we want to have decision mapping flood hazard maps, then we have to incorporate the hydrodynamic modeling. Like we have to incorporate HACRAS, we have to incorporate MIC, etc. for preparing the hazard map, because that will give us depth and velocity also. This is for decision making, but for planning purposes, what we can do, we can use the Google Earth Engine maps also, which gives us hazard maps using the previous year floods. So thank you. So I have a like short activity. So can you, I will share you a link. So I just want to know whether you have like whether you have learned it properly or not. So it's a very short, it's not a quiz or it's not like some marking base, it's just a fun activity. So you can just click on the link, and then you can click on the link, and then you can like give the quiz. Okay, I will share in the group. So whenever you all click and enter your name, you just tell me, I will start. Okay. Enter. Everybody, you have entered. आना नहीं है पहलेगा. Okay. Need to slow से. नहीं हुआ. Net too slow. It's okay then. Thank you. So do you have any questions?
Is AEC doing some work on floodplain zoning based on the technical guidelines of CWC that has circulated?
No.
No.
So maybe in some, maybe no, they haven't done any. Like I haven't gone through any research. Research also, they haven't gone through any of the floodplain zoning.
Has the technical guidelines been circulated?
No,
to
no,
AEC
no.
Also? No.
I don't know. Like I haven't got
Because,
it. Maybe.
They are they are means view of that Indian Institute to give their comments and views regarding the.
Okay, maybe they have gone to the senior faculties, but yeah, not.
Please ensure that it has.
Okay.
Because it's very important. It will be implemented in the next 2 years or 3 years.
Okay.
No. But we are in the process of implementing the flood forecasting.
WRD actually.
That guidelines I have.
WRD actually we have they have now established one section. It's hydroinformatics unit in under water resource department. So I was there only in hydroinformatics unit of water resource department. What they will do, they have considered 3 basins, Beki, Buriding and Jadal, the 3 basins sub basins of Brahmaputra. So for this, it is a pilot project firstly. So for these 3 sub basins, they will prepare the early warning system first. Then during the floodplain management, which is in, I think, in the second phase of the project. So in the second phase of the project, they will try to implement this. They will prepare the hazard map and also the flood zoning maps for these 3 sub basins only. And also there is one project for under ADB. They are also they will for the mainstream Brahmaputra, they will be preparing the hydrodynamic model for the river, and then under that project for Brahmaputra also they will be doing the hazard analysis and then prepare the zoning maps.
They have already done the flood mapping for 5, 25 and 100 for
Breeding and Giada.
So it's on the
Process. Okay, thank you.
11-15 स्टेप 11 पे अच्छा हाँ हो जाएगा जी जी